Hi, my name is Espen and I am the Senior Scientist and Curator for Paleontology here at the Queensland Museum. And in front of me here I've got two specimens of a long-necked plesiosaur called elasmosaurs that existed here in Queensland around 100 to 120 million years ago. So the problem we have had for a very long time with these long-necked plesiosaurs is that when they die, their bodies decompose and their heads often fall off or get snagged off by a scavenger long before it settles on the bottom and has the time to fossilize. So when we're finding them in the field, we often find parts of their body or a body without a head, and a very rare occasion you can find a head and usually it doesn't have a body attached. So this specimen here on my left is exactly what happened with that one. So we have a fairly crushed head here, but we can see the whole head, but it doesn't have any of the body attached, which means that all those other bodies that we find, we don't know what sort of head goes with those bodies and therefore which body goes with this head. And this is where this specimen here that we found in 2022 comes in, Little Prince. So it was found out in Western Queensland by station owners. So this has not just the head, but we also have the entire neck that fits on the back and part of the shoulder and front of the body as well. So this will tie those pieces together, so we can now figure out which body of the bodies we have that are headless fits with this kind of plesiosaur. And that's important because that's the start of how we can unravel how many of these species of plesiosaur were there around. But not only that, these ones are from one age type of rock here in Queensland, about 100 million years old. Then we have another rock unit that is about 120, 115 million years old. So other plesiosaurs like Dave comes from those rocks. And because Dave is a young individual, just like this one here, we can now have overlapping material between those two old style and younger style plesiosaurs and try and figure out were they different or was this a long persisting species here in Queensland over time.
So what we have here on the table is an elasmosaur called Dave the elasmosaur. And this is the first time we've been able to see all the bones without much of the rock on them. So in the preparation lab, we use pneumatic tools to remove some of the rock. And bone is obvious in the field, but this particular animal was embedded in rock. So we had to remove that to see all the details. So what we're doing here is laying it out in a grid pattern. It was recorded in the field in grids, and now we're replicating that on the table so that we can see how everything was. This gives us an indication whether there was any movement when the animal died and it became a fossil, because it's not, as you can see, it's not actually all together. It's what we call semi-articulated. So you can see a line of vertebrae, but they're not basically touching each other. There's little gaps. So there's been some movement after the animal died. So from the field, all these bones, most of the bones were in jackets, and in the laboratory, when they come back to the laboratory, we open the jackets and we look at how much bone we can see. In between the bone is usually rock, and that's what we use the tools to remove. Normally, those two pieces of bone usually connect, and that makes an element that the researchers want to see.
We've been preparing the fossil of Dave the elasmosaur for quite a few years now, and it's really important that we keep him well preserved here in the Queensland Museum collection. The fossil in the field was preserved with minerals such as pyrite, which undergo a decay process when they come into contact with oxygen and water. So we have to put Dave into boxes with oxygen scavengers to create a microenvironment that will keep the fossil preserved for hundreds of years to come.